My name is Seabourn. I'm a PhD candidate in the Department of Entomology. So I'm here to discuss my work on mosquitoes and its potential to prevent mosquito-borne disease. Mosquitoes were first detected in Hawaii in the 1800s, and since then they have been responsible for the transmission of avian malaria and the decline of the native bird populations. They have also been responsible for the transmission of viruses like dengue to humans, with the most recent outbreak occurring in 2015. To combat this, my research is centered around the surveillance of a medically important mosquito, Aedes albopictus, and its microbiome. The microbiome consists of a community of microorganisms that include bacteria, archaea, fungi, protozoa, and viruses that live on or within a host organism. The microbiome influences physiological traits of mosquitoes by interfering with reproduction, stimulating immune responses, and even interacting with the pathogens that it will subsequently transmit to us. These interactions vary, and this is because the microbiome varies significantly within mosquito populations. The variation in the microbiome is why some mosquitoes can transmit pathogens more effectively. This variation is understudied in medically important mosquitoes. So to address this gap, I surveyed Aedes albopictus and its microbiome on the island of Maui for 1 year. What we found was that Aedes albopictus is widespread throughout the island, with its abundance varying at different sites. We were also interested in how different ecological and environmental factors influence the microbiome. So we measured things like temperature, rainfall, and whether or not a mosquito was infected with a parasite. What we found was that these factors do influence the microbiome. For example, some bacterial species increased in abundance when they were exposed to high amounts of rainfall. What this highlights is that the environment does seem to play a role in the giant puzzle of why there's so much microbiome variation. But why do we care? The microbiome can allow us to determine what mosquito populations have a higher risk of transmitting tick-borne pathogens, and even allow us to predict and prevent future outbreaks. Other applications include using the microbiome to create mosquitoes that are incapable of transmitting pathogens. It's very clear that understanding the microbiome variation will allow us to determine and promote future disease prevention strategies. The impact mosquitoes have in Hawaii and globally is still seen, and we need to incorporate new and innovative techniques to prevent mosquito-borne disease. Thank you.